Hello everyone, Pen here. Today let's talk about intent redirection. In web apps, we know what OpenDirect is. We also know what SSRF is. If you don't know, please check it out on official Portswigger site. OpenDirect simply takes a parameter and redirects a user to the parameter's value without sufficient validation. SSRF, on the other hand, causes the server-side application to make requests to an unintended location. Intent redirection is similar to OpenDirect in web apps. Now, for us to get the best out of this video, we must understand what an intent is in the first place. And this is our way as ethical hackers. We sought understanding before going into action. An intent is a messaging object used to request an action from another app component. There are two types of intents, explicit and implicit. Explicit intent has a specified component and the exact set class to run when invoked, whereas an implicit one lets the system decide what components are best to the exact class for the intent. An intent will contain such information as component name, action, data, category, extras, flags, and etc. On your right is a small code snip of how an intent looks. We also need to understand what a pending and nested intent is. Pending intent refers to a wrapper around an intent object. Its purpose is to grant permission to a foreign application to use the contained intent as if it were executed from app's own process. A nested intent, on the other hand, is an intent passed as an extra parameter to another intent. Enough of background knowledge. Intent redirection, according to Android, occurs when an attacker partly or fully controls the contents of an intent used to launch a new component in the context of a vulnerable application. The most recent example is CVE 2024-26204, Information Disclosure Vulnerability on Microsoft Outlook for Android. Let's analyze this diagram from Android to better understand this. Let's consider two applications, one client and the other service. Assume the client is the app you control. At one, your app creates an intent that invokes an activity in service app. Within the intent, you add a pending intent object as an extra. This pending intent invokes a private component in your app that's not exported. At 2, the service app extracts the nested pending intent object. At 3, the service app invokes send method on the pending intent object. And at 4, this breaks your client's app private control and the system invokes the pending intent using your app's intent content, thus assessing your app's private component. That's simply what intent redirect is, using a content of an intent to execute internal functionality in an application. Normally, private functionalities. This often leads to critical information disclosure, including compromising content providers. I'm actually going to make a video on hacking content providers soon. Be sure to subscribe so you don't miss out on future videos. It can also lead to stealing user authentication sessions, cookies, depending on the functionality of the app component in question, especially if the component is web views. As usual, we learn by doing, so let's get into the hands-on demo part. We've already talked about static and dynamic analysis of Android apps in the previous videos. If you have not, please go and watch for a refresher. I'm saying this because we are not going to talk about the analysis here, but on how to exploit intent redirection. However, bear in mind that like web apps and every hacking aspect, you must know how to identify a bug. This is the most important part. If you want to hunt for intent redirection, there's some indicators you need to look at. Look for intent extras. You can search them directly after decompiling an APK and going to the most promising functions. Another way is analyzing an application functionality dynamically as a whole. Start the manifest XML file. Take note of those protected components that are explicitly declared not exported. That's where critical bugs lie. Go through the app flow from entry points such as login to the main ones and finally the exit one. When you understand how an application processor handles its requests for various functions, you get a lot more bugs, and intent redirection will definitely be one of them. Now, let's go direct to the over app. The login activity, to be specific. When this activity is started, the onCreate function at line 28 performs some checks. One of those checks is if the user is logged in at line 33. If he is, another function on login finished is called. Otherwise, it proceeds to the else section where the user will have to log in using email and password. And there is a function process login that checks the credentials. Now, again, under this function at line 74, it also calls on login finished function. The login finished function is just right below at line 77. An intended direct intent is initialized and assigned to the calling intent with the extra data intended direct key as a parameter. Checks are done on this redirect intent at line 77. If this intent has data with key name redirect intent, then the activity specified in this intent is started. And this is where the bug is. It means if we can control this redirect intent and direct it to an unexported activity of our choice, then we can use this login activity class to launch it for us and have access to its internal functionality. And in simple terms, that's what intended direction is. We are directing an intent to open a component of our choice. This is going to work if the login activity is exported and the activity we want to redirect our intent to is not exported. Otherwise, we can start it directly without having to do this hassle. Going to manifest XML file, you realize that the login activity is exported. Well, some might argue that it's not, but if a component has an intent filter, then by default it's exported, unless explicitly exported false. The activity we are interested in is WebView activity, which is not exported, as you can see. Exported is set to false. If you've been watching my videos, then you know that web views can be hacked remotely via internet. They are always interesting components for hackers. Going to this class, you realize that it loads a URL directly from a calling intent with extra data named key URL. No validation done whatsoever. The setup web view function at line 23 is even more interesting. It has JavaScript enabled at line 28. As an Android hacker, you know what that means. It means you can write and run arbitrary JavaScript code inside this application, and especially XSS rings in our mind. We are, however, not going to do that in this video. I think I covered this in a previous video. Please go and watch it. To demonstrate this whole exploitability, we'll have to create an external app. I found a code written by Payatu to quickly put this together, and I have referenced the official page in the video description below, where you can check a whole lot of other Android app bugs for this app. I'll also include this exploit app in my GitHub repo, so you don't have to worry. We are going to create an Android evil app with the function login redirect. We create two intents. The first one, called protected activity intent, will start the WebView activity. The action is WebView, and we are going to pass an extra data key named URL with the value of any site you may wish, and in this case we are passing in google.com. Remember, the WebView activity is not exported. The second intent, named login intent, is set to login activity class with intent data extra key named redirect intent assigned the value of the protected activity intent. Protected activity intent here is a nested intent. And finally, this login redirect function will start activity using the login intent. This is what happens in a nutshell. Login redirect function will start an activity using a login intent, which has set class login activity with extra data from protected activity intent. This protected activity intent, remember, has set class WebView activity. Action is set to WebView, and there is an extra data URL which we have specified as Google. This is the whole data that is passed as an extra to login activity, and hence a Google page is open inside the application using login activity. It's that simple, but actually complex. Take your time and you will understand this. If I'm speaking faster, of which I think I am, you should pause the video bit by bit to digest and understand what's going on. We build an APK of this and install it on our emulator that has oversecure over app also installed. We install by adb install command, and as you can see, it's installed. Let's open and see what happens. On opening, you can actually see that it opens WebView inside of a secured app with full functioning Google search web page. Think of the Google URL as a URL you control. A hacker can use that to perform social engineering on users, and the consequences of this kind of attack is dire. As a mitigation, don't expose functionality related to redirecting nested intents. Instead, use pending intents. Also, remember to sanitize the bundle information. Check official Android dev documentation to learn more about this. If you find this helpful, please share and subscribe. Also, if you have any questions, suggestions, feedback, please comment in the comment section below. And that is it for now. See you, and you're welcome.